Hello students, so I'm back with another interesting question, and this is a question that combines two very interesting reactions in the form of a conversion, and it's a multi-step question, and give it a try. It is a bit challenging in some aspects, but it can be done if you are clear with your concepts. So I'm showing the question. So we have been given hexanone, cyclohexanone, and the reaction proceeds. So to proceed with the solution, we have been given cyclohexanone as the starting substrate, and it is reacted with something like this in the presence of an acid catalyst. Now this reagent is very similar to what we use as ethylene glycol, which is used as a capping reagent or capping source for the ketones and aldehydes present in compounds. So this shall do a very similar thing, and we get finally a compound like this. So this is our compound A. Now this compound is treated with a strong base NaNH2, and this shall undergo acid-base reaction, and it ionizes the most acidic hydrogen, that is this one. So this, when it ionizes, it forms something like this. A carbon ion is formed. This is the carbon ion formed, and the second step in this reaction only, it reacts with CH3I. So this attacks as a nucleophile, and we get something like this. So a methyl is added to the compound. Now this, when hydrolyzed, removes this part, and we get back the cyclohexanone part with a methyl added to its neighboring position. Now this substance is further reacted with NaBH4, which is a reducing agent, and we have been instructed to strictly consider the cis product. So this far this was B and this was C, and now we are going to give the cis product from this reaction, which is, if I draw it like this, is something like this. So this is the cis product that we are given. This is D. Now D is reacted with OAC, so it gives we get this, which is an ester, and I'll just clean up the space, and we'll proceed with a final, a very crucial step of this entire conversion. Now to proceed with the last step, that is, we are treating E with two different reagents, that is, heating it in the presence of a base like ETO minus, and heating it in the presence of itself and no other reagent. So in the first case, we just get a normal E2 elimination, and the ETO minus abstracts this hydrogen, and the OAC group acts as a leaving group. So this is what we get as our product F. This is our major product, and this is our only product if we want to see. So this is F. Now what happens if we heat this compound without any extra reagent? What happens is, if we open this up a bit, this is equivalent to something like this. Now what happens is, on heating of this compound, this ester undergoes pyrolysis, and as a result of which this double bond is formed here. So let's see the mechanism of this particular reaction in a bit simpler molecule, so that you can understand the mechanism and the transition states better. So let us consider a compound like this. Now what happens is, this forms a 6-member cyclic transition state on heating, and this bond rotates here, and this bond rotates here, and this opens up. So on heating we get the elimination like this, and we get CH3 CH3COO minus, or rather CH3COOH. So there is an elimination, which is a rather um, Hoffman elimination kind of thing, and this occurs because of the formation of a 6-member cyclic transition state, which involves the removal of the most acidic hydrogen present in the molecule. Now this formation had two options, this hydrogen or this hydrogen, hydrogen A or B, and on analyzing the acidity of these two hydrogens, we get that hydrogen A is more acidic, and hence that goes the elimination. So similarly, when we are reacting with this, to be noted, this is a very stereospecific reaction where the hydrogen needs to be in the same side of the leaving group, as it forms a cyclic transition state. So on analyzing this particular given molecule, see that the ester has only one hydrogen adjacent to it, which is on the same side, and for this pyrolysis of ester, the reaction is highly stereospecific, which requires the hydrogen to be on the same side as the ester, and as a result of which the elimination takes from this site, and we get, on elimination, we get something like this as a major product. So this is G. So this was the compound, and this was the entire conversion. It had two major steps. That is, the first step, which included the capping of the ketone, followed by addition of a methyl group, which is not a very common reaction and not a very common pathway for such a addition. And the second very important concept covered in this conversion was the pyrolysis of esters. So this was the question. It was a very interesting one, and it is surely something that you can expect in a JEE Advanced examination. So do comment down whether you were able to solve the question on your own or you learned something new from this video, and keep learning.